Alright, you guys, this is going to be the unit guide, the study review for the Unit 7 test. So, first of all, graphing exponential and logarithmic functions described as an exponential growth or decay. The way to do that, we know we've got y equals ab to the x. We're looking at the number with the exponent. If b is bigger than 1, it's a growth. If b is smaller than 1, it's a decay. So right here, 5 is a, b is 2/3. 2/3 is smaller than 1, so this is going to be a decay. In this situation, a is 1/3, b is 6/5. 6/5 is an improper fraction. 6 is bigger than 5, which means that it's actually bigger than 1. So this is going to be a growth. All right, next up, graph each function and identify each characteristics. If you do not do anything else but put this in your calculator and look at the table and graph it on your graph, by all means, at least do that. So, that sends me over the edge. Y'all make sure you graph it. So you're going to go to y equals 3. And if you don't know how to do it, by all means, tell me. Go to your y equals, which is here, y equals 3 raised to the x plus 1 power, and I'm going to get out of there, minus 6, graph. And there is my graph. There is no reason y'all should not be able to graph this. Go to your table, grab some numbers, x and y. Let me tell you, this -6 is important. So I'm going to start kind of going, these are way too big numbers, but when I start getting into 1, 3, 0, -3, -1, -5, and then you're going to start noticing that they're going to get closer and closer to -6, right? We talked about that. I can at least plot those 3 points. -1, -5, 0, -3, 1, 3. And I know that the graph is going to look something like this. I can graph this. Now, what you need to know is that right here, that's your asymptote. That value right there is your asymptote. And we know that your asymptote is a horizontal line. And when we think of a horizontal line, we think of HOI. Horizontal line of HOI, which means that the equation is going to be y equals -6. So at -6, I'm going to draw my asymptote, a horizontal line right at -6. And then when I graph my graph, that graph is going to run right along that horizontal asymptote. If nothing else, at least do that. Now, my y-intercept. Well, I know my y-intercept is going to be where x equals 0. 0, -3, right? I can certainly find that on the graph. My range, where, going from the very bottom to the very top, where does the range begin? It doesn't touch, but it gets very, very close to -6. Y has to be, y is above, y is greater than -6. It's not greater than or equal to because it won't ever touch that asymptote. And my domain, I've got arrows pointing this way, arrows pointing out at a very slight line that way, is going to be all real numbers. And you don't have to worry about the limits. All right, hopefully you're getting this. We're going to go a little bit faster. So here you've got, and judging by this value right here, I know it's going to be a decay. So I'm going to graph my line. Y equals 1/2 raised to the x minus 5 power plus 2. I'm expecting that graph to move up 2 and translate to the right 5. We'll talk about that in a minute. But graph, you can see it's raised up 2 and is translated to the right 5. Because we know that this makes it go left and right. This makes it go up and down. The parent value, the parent function. So I can go to my table. Again, these numbers are way too big. I got to find numbers, and it's always going to be around that. Whatever that number is, those are going to be graphable numbers. So, x, y. What are some graphable points? 2, 10, 3, 6, 4, 4, 5, 3. And then it's going to start approaching the asymptote here, my horizontal asymptote. I'm going to just pop up here real quick and see when x is 0, y is 34. That's important for my y-intercept. My horizontal asymptote is this value right here, y equals 2. And you can see from the graph, it doesn't ever, it's going to approach but not ever touch the 2. Now I can graph 2, 10, 3, 6, 4, 4, and 5, 3, and that asymptote right at positive 2. Now, and that line's going to just skim right on top of the asymptote. My domain, arrows going in both directions of the x values, all real numbers. My range, y is, the graph is above, greater than, whatever the asymptote is, 2. These are related. And then I don't have to worry about that. Alright. Now, we did not go over graphing logs, so don't worry about that one. Don't worry about this one. Alright. Now, right in logarithmic form, right, we're going from exponents to logs. So we're going from a to the x. Oh wait, I think we did b to the x equals a. And that's the same as log base b of a equals x. Working backwards and forwards, right? So this is going to be log base 8. 64 equals 2. Log base 2 of 32 equals x minus 4. It's just telling me to write it. I'm not solving anything. I'm just writing it. Log base 10, so I don't have to write anything because we know that when there's no base written, it's an automatic assumption of base 10. And here, log base e of x minus 2 equals 6. And the important thing here is then you need to write ln x minus 2 equals 6. Will I mark off if you don't write ln? Yes, I will. That's not correct. So there you go. Now in exponential form, so now I'm changing them back to exponents. So I'm going now from log form to exponent form. So 3 raised to the third power equals 27. Again, I'm just writing them. I'm not solving them. X to the 1/2 power equals 7. 4 to the x power equals 90. And here my base is e to the 38 power equals x. Right? Okay, moving on. Evaluate each logarithm. Use the change of base formula when necessary. So your change of base formula is log of a divided by log of b. Alright, so these ones, you're going to have log 81 divided by log 9. This you really don't need to use your change of base formula, but we'll do it anyway. Alright, I'm not going to go through these. These are all going to be the same. Here is just going to be your ln button of 42. And go to 3 digits. Alright, moving on. Your product rule and your quotient rule. So this is condensed. And the expanded version is going to be log bm plus log bn. Generally, you're going from this version to the condensed version. So this is your condensed version. Now the expanded version is log bm minus log bn. And your power rule is going to be n log b of m. Okay, so here we are adding, and we have this. So since we're adding, we're going to use the product rule. This is going to be 2 squared, or 2 to the third power, sorry, log of 2 to the third power. I've moved this to there, times x minus 4. Well, 2 to the third power is 8. So if you want me to write this down like this, then when I multiply that out, it's going to be log 8x minus 32. Now keep in mind, I still have this word log here. I haven't got, the only time you can get rid of that log is when you're solving and we have logs on both sides, which we'll talk about, or when you change it to exponential form. Don't drop that word because it's not going to be the same value. So we've got here, we've got this raised, so log base 5, 324 raised to the 1/2 power. 1/2 power is your square root divided by 2. So 324, I think that's going to be 18, but let me just double check. The square root of 324, 18. So this is going to be log base 5, 18 divided by 2, log base 5 of 9. Alright, last one. Now we've got a natural log. The natural log still going to be the same. ln 6 to the third power divided by, because that's what that is, 4 to the 3 halves power. So now I've got to do some calculations here. ln 6 to the 3rd power is 216. Oh, dang it. I didn't mean to write that equal sign. ln 216 divided by, now keep in mind this is going to be 4 to the 3rd power and the square root of that, right? 4 to the 3rd power is 64. The square root of 64 is 8. If you really must, you can do 8, or I'm sorry, clear. You can do 4 to the 2/3 power. Oops, I'm sorry, 4 to the 3rd. Holy mackerel. 4 to the 3 halves power. And get 8. So now you bring this down. ln 216 divided by 8 is going to be ln 27. Hopefully you guys are knowing how to do this. Alright, now you're going to expand. So we're going from this version to the bigger version, the longer version. So here, if you first want to distribute your exponent. So log base 3 x to the 6th, I'm multiplying, yes, I'm multiplying, because it's raised to the exponent. It's not, I'm not multiplying the the exponents together, right? Don't confuse x squared times x to the 4th, x to the 6th, where I add the exponents, with x squared raised to the 4th. I'm going to multiply my exponents. That's what I'm doing here. I'm multiplying these exponents. Now I need to separate those out. I move my 6 in front. 6 log 3 x. I'm multiplying here, so I add sign. 15 comes in front. Log y. That's your expanded version. Same here. I'm going to have ln 2 to the 4th over a to the 12th. So now when I expand that, it's going to be 2 ln, I'm sorry, 4 ln, goodness gracious, 4 ln of 2 minus 12 ln of a. And there you go. And this last one, keep in mind that the square root is 1/2. This is going to be 1/2. So I can rewrite this as log to the 4th p to the 3 over 2 q to the 10 over 2. I'm multiplying that exponent by 1/2. 1/2 times 3 is going to give me 3 over 2. 10, 1/2 times 10 is going to give me 10 over 2, which is going to be 5. I move this in front. 3 halves log base 4 p plus, because I'm multiplying here, 5 log base 4 of q. Alright, so that's the end of this video. I will do another one of the rest of the review.